Hello everyone, welcome to my YouTube channel. This is Enoch's tutorial. Don't forget to like and subscribe after watching the video so you can receive every update from this channel. In today's video, we're going to look at some summarized organic synthesis in organic chemistry. We are going to look at the various syntheses around alcohols and the reactions of alcohols, and go to the synthesis and the reactions around carboxylic acids and their derivatives. Don't forget to subscribe after watching so you can receive every bit of updates from this channel. So let's begin. Let's look at the various reactions that alcohols can undergo in organic chemistry. These reactions involve the ways of synthesis of alcohols or conversion of other compounds to alcohols. So it can be conversion of alcohols to other compounds or from other organic compounds back to alcohol. The first one you want to look at is the reaction between alcohols and alkanes. So alkanes are basically hydrocarbon with a double bond. That is, they have a carbon-carbon double bond, in which one bond is a sigma bond and the other is a pi bond. If you have an alcohol and you treat it with an aluminium oxide for dehydration, so this reaction is more of a dehydration reaction. So you move water from the alcohol, you convert the alcohol to alkane. So dehydration of alkanes at a very high temperature converts the alcohols to alkanes. In the same way, if you hydrate the alkanes, you get the alcohol. So these reactions are more of a vice versa reaction. If you dehydrate alcohols, you remove water and create a double bond between two adjacent carbons, that is one holding the hydroxy group. Whereas if you hydrate alkanes in acidic condition, you convert the alkanes to alcohol. So that's a summarized reaction between alcohols and alkanes. Let's look at the one that exists between alcohols and haloalkanes. So haloalkanes are basically alkanes in which one of the hydrogens has been replaced by a halogen. So you can convert an alcohol to a haloalkane by reacting it with HBr. The HBr after dehydration or heating. After heating, so if you heat, you tend to replace the hydroxy group of the alcohol with the Br, or if it's HCl or Hi or any other hydrogen or hydrogen halide, the halogen portion replaces the OH group of the alcohol and forms the corresponding alkane or haloalkane. In other words, the reversible reaction of this is treating the haloalkane with a potassium hydroxide in water. This reaction is more of a nucleophilic substitution reaction in which the hydroxy group of the KOH replaces the halogen on the haloalkane to form the corresponding alcohol. So this reaction is also a reversible reaction that converts alcohol to haloalkane and from haloalkane back to alcohol. Let's see the one that exists between alcohols and ketones. So if you have an alcohol and you oxidize it, you can form a ketone. So sodium chromate is an oxidizing agent that converts alcohols to ketones. Basically, secondary alcohols under oxidation forms ketones, but primary alcohols under oxidation forms aldehyde. That's why you have here this one. This is same sodium chromate forming alcohols from or aldehyde from ketone. So aldehydes can form from alcohols if the alcohol is a primary alcohol, but ketones can be formed from alcohol if the alcohol is a secondary alcohol, all by oxidation reaction. In other words, we can form ketones or can form alcohols from ketones also by reduction with lithium aluminum hydride. We oxidize alcohols to form ketones, or you oxidize secondary alcohols to form ketones, then we form back alcohols from ketones through reduction reaction by using lithium aluminum hydride as the reducing agent to reduce the ketone group of the ketone to OH group to form an alcohol. We can equally form, as we said earlier, an aldehyde from alcohol by oxidation, and also form alcohol from aldehyde by reduction. So this is a reduction reaction that converts or that interconverts between aldehyde and ketones. One is oxidation and one is reduction. We can once again oxidize alcohol into aldehyde and further oxidize aldehydes into carboxylic acids. Or we can oxidize the alcohol with a strong oxidizing agent to form carboxylic acid straight. An alkoxide ion is an alcohol that has lost one hydrogen. An OH group which has lost one hydrogen keeps the oxygen with a negative charge. Such ionic alcohol is called an alkoxide ion. If you treat an alcohol with metallic sodium, the sodium abstracts the hydrogen and forms a sodium hydride. Then the resulting ionic compound or the resulting conjugate base of the alcohol is what we call an alkoxide ion. So a reaction between alcohol and sodium metal forms an alkoxide ion because this sodium forms a sodium hydride by abstracting the external or the outside hydrogen from the hydroxy group of the alcohol. So this is a summarized reaction that surrounds alcohol. One, they can interconvert between alcohols and alkenes, alcohols and haloalkanes, alcohols and ketones, alcohols and carboxylic acids, alcohols and aldehydes, and alcohols and alkoxide ion. Most of these reactions are by oxidation reduction reaction or let's say halogenation and dehalogenation reaction, or let's say hydration and dehydration reaction. They are reversible because if you get this, you can reverse the process to get back the initial reactant. Let's see the reaction that surrounds carboxylic acids. So carboxylic acids are compounds with carboxylic group, that is COOH group. That group defines a carboxylic acid. Let's see the various synthesis and the reaction that carboxylic acid can undergo. We discussed earlier that carboxylic acid can be synthesized by prolonged oxidation of alcohols to form them, or an oxidation of alcohol to form an aldehyde, and further oxidation to form carboxylic acids. Carboxylic acids can undergo what we call an esterification reaction by reacting with alcohol to form an ester. So a carboxylic acid undergoes an esterification reaction to form an ester of an alcohol, an ester and water. So an esterification reaction is a reaction between an alcohol and carboxylic acid to form an ester and water. Once again, if you have an ester, you can reversibly hydrolyze it, that is by hydrolysis, to form back the carboxylic acid and the alcohol. So this one too is more of a reversible reaction. An acyl chloride is a carboxylic acid whose hydroxy group has been replaced by chlorine. So if you have COOH, the OH will be replaced by Cl to form an acyl chloride. An acyl chloride is a derivative of carboxylic acid that forms when you treat a carboxylic acid with thionyl chloride. Acyl chlorides can be converted to esters by treating them with alcohol, also by esterification reaction, or they can be converted to amides by treating them with ammonia or an amine. So this reaction, converting acyl chlorides to amide, is a nucleophilic substitution reaction in which the Cl of the acyl chloride get replaced by the NH2 from the NH3, or if it is an amine, the amino group bonds to the carboxylic group of the acyl chloride to form the amide. With esterification reaction, the alkoxide ion of the alcohol replaces the Cl group of the acyl chloride to form the ester. So ester can also be converted between alcohols by hydrolysis. So when you hydrolyze ester, you are going to generate the carboxylic acid and the alcohol. And if you treat alcohols with carboxylic acids, you are going to get back esters. So these are a summary of main organic synthesis that occurs in organic chemistry. All these compounds are the chief organic compounds in organic chemistry: alkenes, alkoxide ion, alcohols, aldehydes, ketones, haloalkanes. You can have carboxylic acids, esters, alcohols, acyl chlorides, and amides. So these are the main, or let's say the central organic compounds that exist in organic chemistry. Some few others exist, but these are summarized way of reaction or the synthesis of these known organic compounds. Thanks for watching. Don't forget to subscribe for watching so you can receive update from every bit of thing we put on this channel. Shut up this Enoch tutorial. Thanks for watching. Thank you.